Hello students, today we are going to learn Hayes bridge. Hayes bridge is used for high quality factor measurement and it is a modified version of Maxwell's bridge. As we can see here, there are four arms A, B, C and D. In arm AB, we are having a resistor connected in series with capacitor. In BC, we are having the resistor R2. In CD, we are having the unknown impedance, that is Lx, connected in series with Rx. And in AD, we are having the resistor R3. We will assume that this bridge is in the null condition, that is no current is going to flow through the detector. That time Z1 into Zx will be equal to Z2 into Z3. I can further write Zx as Z2 into Z3 divided by Z1. Now, I will number this equation as 1. My Z1 is a resistor in series with capacitor. So, I can write it as R1 minus J omega C1. My Z2 is a resistor R2 and Z3 is also a resistor R3 and my Zx is a resistance in series with a inductor. Now I'll substitute all this Zx, Z2, Z1 and Z3 in equation 1. So I'm going to get Z1 is R1 minus J divided by omega C1 into Zx. Zx is Rx plus J omega Ls. This will be equal to Z2 into Z3, that is R2 into R3. Now I'll open up this bracket. So I'm going to get R1 Rx plus J omega Lx R1 minus J Rx divided by omega C1. Now here minus minus J, it is going to become plus. So it's going to be Lx divided by C1. This will be equal to your R2 into R3. Now I'm going to equalize real and imaginary parts. If you see a real and imaginary part, equalization is going to give me R1 into Rx. So this is real. This is real component. Then we are having this real component and this is a real component. So what I'm going to get is plus Lx divided by C1 is equal to R2 into R3. After that, we will equalize imaginary terms. That is going to give me Rx divided by omega C1 equal to omega Lx R1. So what is my Rx here? If I see Rx is going to be omega square Lx R1 C1. Okay. Now I'll mark this equation as equation number 2 and I'll label this as equation number 3. After this, I will substitute Rx value in equation 2. So that will give me, okay, substituting Rx in equation 2, we are going to get, okay, R1 into omega square Lx R1 into C1, okay, into, plus Lx divided by C1 equal to R2 into R3. Okay. After that, I will group all the Lx terms together so that I will get the value of Lx. So I'll take all the Lx terms together. It comes to Lx, it will come to omega square R1 square C1 square plus 1 is equal to R2 into R3. So I can write my Lx as equal to R2 into R3 into C1 divided by, okay, omega square R1 square C1 square plus 1. After doing this, I'm going to substitute, okay, I'm going to substitute Lx in 3. Then I get it as, okay, after doing that, I get my Rx value as omega square R2 R3 R1 C1 square divided by 1 plus omega square C1 square R1 square. Okay, that's all for today's lecture, students. Okay, thank you.